Alright, so we're going to go over the GK practice pretest. A lot of people ask for them, and we usually go over them in tutoring, but in case you want to look at them again or something's just catching you up, you're not quite getting it yet, this video is for you. Alright, so we're starting with number 1, which we have 4 plus -7 plus 2 plus -5. So I'm going to go ahead and write that as 4 plus -7 plus 2 plus -5. I'm going to look here first, and I'm going to identify everywhere I have brackets. I'm going to look at the leading sign, knowing that here there's also no coefficient here, so it's an understood 1. If I distribute this in, a +1 will not change the sign, and here again a +1 will not change the sign. So I'm going to go ahead and distribute them in. I'm going to have 4 plus -7 plus 2 plus -5. Could have also written it as 4 minus 7 plus 2 minus 5. If you look at this, this is the same as plus -7. So whichever you're more comfortable with is the way you can do it. I'm going to go ahead and do it where we just drop the parentheses, since that's how it's represented on the test, and we'll just go from there. So I'm going to combine 4 and 2 to get 6. Then I'm going to combine -7 and -5 and end up at -12. We had a plus sign here, so we're going to go ahead and put the plus in. 6 plus -12 leaves me at -6. That is how you do number 1. Alright, let's switch over to number 2 real quick. So how would we do this? What integer makes the equation -13 plus 12 plus 7 plus x equal 10? So now we actually have an equation. Well, what it's really asking is what value of x balances this equation where you come up with a +10. So we're going to switch back over and we're going to work this one out real quick. And we're going to write down -13 plus 12 plus 7 plus x is equal to 10. So the first thing we're going to do is we're going to combine all the constants here. -13 plus 12 is -1 plus 7 is 6. We still have the variable x, and that's a plus x equal to 10. So now all I have to do is find out take 6 from both sides, and x is equal to 4. How would we test that? Well, we would take -13 plus 12 plus 7 plus 4 and set it equal to 10, and we'll find out if that's a true expression or equation. Well, again, we have -1 plus 11. We can say that's plus 11. 7 plus 4, and that does equal 10. 10 is equal to 10. It's true. Therefore, this is the correct answer. All right. Let's move on to number 3. This is our first word problem. In the St. Elias Mountains, Mount Logan rises from 1,292 meters above sea level to 7,243 meters above sea level. How tall is Mount Logan? So at first, it's asking how tall, so we know we're going to do a difference equation or subtraction. But the trick lies in knowing exactly what the question's asking. So we have a mountain here. Sorry, it caught me in the middle of drawing the mountain. Alright. So Mount Logan rises from 1,292 meters, so that's the base, from meters above sea level to 7,243. That's the peak. So what it's really saying is, here's your land. There's a little guy looking up, so you know. And then if you were to continue out, you're actually 1,292 feet above the sea level. You have the sea out here. So what we need to do is figure out how tall it is. Well, the peak is 7,243, and its height above sea level is 1,292. We just do this quick subtraction, and we get 5951. All right. Get back out of this one. That one's really tough. A lot of people come to me. That's usually one of the ones everyone misses. So if you miss that one, no need to feel bad because it's pretty common. All right, here we're just simply simplifying expressions. We're going to have -3 times -18 times -1. So let's switch back over. All right. So we have -3 times -18 times -1. 18 times 3 is 54. Let's do our signs now. Double negative makes this as positive times -1. Negative times positive is equal to a negative. -1 times 54 gives us -54 as our final answer. All right, number 4. We have the absolute value of -42 times the absolute value of 7. So what absolute value basically is how far away is it on the number line from 0, or the magnitude, which you'll learn in higher math classes, but let's just do number 7 really quick. So we have 0, try for a straight line. Hey, we got pretty close. All right, so we have 1, 2, 3, 4, 5, 6, 7. That's where positive 7 is. Let's do -7 real quick so we can look at both ways. Alright, so the absolute value is asking how far from 0 is this value, 7. So if we count the ticks, we have 7. And then again, if we count the ticks, we still have 7. So it doesn't matter which side of 0 it's on. 7 is 7 away from 0. If we expand this thought out 6 times further to 42, we're going to be able to see that, well, 42, a little break in our line, and we'll continue it out. So we can come out here and say, well, if 7, the absolute value, either way, positive or negative, is 7 away from 0, then if we come to 42 and -42, we're actually going to end up 42 places away from 0 either way, and that's our absolute value. So that's really what it's asking. So it doesn't care. Negative signs inside an absolute value mean nothing because it's how far from 0. Well, it's 42 places, so we can drop it. What we're going to end up with is 42 times 7. 280 and 14 is 294. So our answer will be 294. While I'm erasing this, let's move on to the next one. Number 6. Okay, this one's a little bit different right away. I'm going to be quiet for a second and let you look at it and see if you see the big difference and how you think that's going to affect our answer. Alright, so let's switch back and look at the problem. Well, what's different here is now we have a negative sign outside of the absolute value, so whatever the product here is going to be, it doesn't matter how far from 0 it is. That's not what it's asking. It still wants it to be negative. There's no absolute value outside of this. So the final answer will not matter how far from 0 it is. So it can be negative. However, inside we have -6 times 8. We can actually do the absolute value. An absolute value of 6 is 6 times 8. So we're going to bring our negative down. Alright, 6 times 8 is 48. But now we still have this guy on the outside. So we're going to have -48. You can distribute it in, or just realize that once you do 6 times 8, drop the brackets, parentheses, and you're ready to go. We're ending up with an answer of -48. Looks like we have a word problem coming up next. Alright. At the end of the year, a small firm has $2,996 in its account for bonuses. The entire amount is equally divided among 14 employees. How much does each one receive? Well, this one's pretty easy and straightforward. We have some keywords here. $2,996. And we have 14 employees. So if we have to divide it equally among the 14 employees, all we have to do here is 2996 divided by 14, 10 would be, yeah, 10 would be 140, so 20 would be 28. Still have 196. 14 times 14 would be 196, so we have $214 per employee. Don't worry about the mental math part of it or anything. You have a calculator, make full use of it. All right, let's see what's next. All right, now we're simplifying expressions. Don't want the old problem back. All right, so for this one we have 4 plus 8 times 2 over 5 minus 1. All right, so we're going to do the order of operations, which we've covered in another video. If you haven't seen it, check it out. But remember, it's PEMDAS. Now, here's something. Anytime you have the division bar, everything on the numerator is technically within a bracket. But we're not going to violate order of operations with what we're about to do. Well, we're going to come in here, and we're going to end up with 8 times 2, which is 16, plus 4. So we're going to end up with 20 over 5 minus 1, which is 4, giving us an answer of 5. Alright, so we have our brackets here, which I've marked in red, and we have our brackets in green that I've marked in green. So we're going to look first. There's a bracket between these, but there is no bracket between these, so this is where we're going to start. We're going to have 12, and then we're going to look at the red. So now we have 12 times 3 in these brackets, giving us 36. And we're dividing by 9, giving us 4. That's our final answer. Alright, let's switch back over. We are looking at number 10. Let me erase this other one really quick. We have 32. So I looked here and I identified that I have division, but I do not have parenthesis or exponents. So now I went to multiplication and division, only division. So I went ahead and did those in red for you. And then I have addition and subtraction next, which I have. So I'm going to go left to right. 20 minus 5 is 15. And next we move on to number 11. Which is write each improper fraction as a mixed number in simplest form, and we have 42 over 3. Let's switch back over this time without making that mistake. And we're just going to figure these out. You take your numerator. Let's go ahead and mark them so we know. We're going to divide our numerator by our denominator. I'm going to have 42 divided by 3, 1, 3, 12, 4. The answer is 14. Switch back. And now we have 50 over 4. Same thing, but it does. This one's probably not going to work out because I know 12 times 4 is 48, so we're not going to have such an easy one. So it's numerator divided by the denominator. Denominator is 4, numerator is 50. Oh, 1 gives me 4, gives me 1, 0, bringing this down. This goes in 2, 12 like I thought, giving me 8. Well, now we have 2. So I can keep going for the decimal, which we'll do, and then I'll show you another way to do it. So can't go into 2, and I'm going to have to create a 0 here, which means I now need a decimal here to bring this down. Well, 4 goes into 20 exactly 5 times, so we're at, here's our options to look for. Wow, that's an extra O because I'm still learning this. We're going to look for 12.5 on the test. But what happens if it's not available? So our other option, we have 4 into 50, but we're going to go ahead and speed this up. Bring this here, do this, 4, 10, 8. So what do we do now? Well, we have 12. We're not going to do this like last time, so we're going to end up with 12.5 again. I'm going to take the whole number 12, and I'm going to go ahead and put it down as part of my answer. So I always box my answers in. So I'm going to go ahead and make the box. Then I'm going to take the denominator, and I'm going to put it at the bottom. And I know I have a remainder of 2, so that's going to be my new numerator. Those are the parts to my whole. And I have 12 and 2/4. Well, that is not going to be on the test because it's not in simplest terms. So what are we going to do? Does 2 go into 2 and 4? Yes, it does. It goes in once and twice. That's your other option. Is 12.5, or which these are equivalent. So that's a good sign that we did this correctly. All right, let's see our next problem. 17/5. All right, this one sticks out right away as we're going to be able to employ both of these strategies again. We have 17/5. Now you can do it. This is the way I usually do it. 5, 10, 15. So I know I'm going to have 3. 17 minus 5. Sorry, minus 15 is equal to 2. I'm going to have 3 and 2/5. That's my way. It's, I don't know. You don't have to do it that way. We're going to do it both ways, but now we're going to look at it as the way we did it before. Well, we have 3. 15, 2. Can't do anything. We need to bring this 0 down. Go ahead and put this in. And we know that that's going to be 4. So our potential answers are 3.4. 3 and 2/5. Well, let's see. Can we check this really quick and see if these are equivalent? Because these aren't as obvious to everybody that they are the same. So what would I do? Well, I know that this is 3 and 40 tenths, or 40%. So if we were to convert this into a percentage, we would have 340%. So how would I do this one? Well, I know I need out of 100 to find percents, so I'm going to have to multiply both by 20 over 20, leaving me with 40 over 100. And I have the whole number 3, which if we were to make that out of 100 would be 300 over 100 plus 40 over 100, giving us 340 over 100. We have equivalent values. All right, so we're good to go on that one. What is next? All right, now we're adding and subtracting fractions. So the number one thing we need to know about adding fractions is they have to have the same denominator to add them. So if we have 5/12 plus 3/12, can we go ahead and add those together? Well, let's look at the denominators. They're both 12. We're good to go. So we're going to be given 8/12. Well, that is the correct answer. Are you going to see it on the test? No. Why will you not see it on the test? Well, we can divide this by 4. We can divide this by 4, which gives us 2/3. If you don't see that right away, we can do it this way. 8/12. We'll go and divide by 2. We'll end up with 4/6, and then we should recognize right away that these can both still be divided by 2, giving us 2/3. So those are both your options to do it. This, if you're more comfortable with it, is a safe bet. Don't get ahead of yourself. This is not going to be a 2-minute problem, so allow yourself the full minute and bank the other one. Don't get ahead of yourself. Don't make a mistake because you want to rush through it. This is not the time to do it. This is a problem that you can bank a minute even if you go the long way, and double check yourself. Alright, number 15, we have 4 and 7/8 minus 3 and 1/8. Now this is another easy one. We have 7/8 and 7/8 here, and we have whole numbers. So we're going to identify our whole numbers with a line and our fractions with another line. 4 minus 3 gives us 1, and 7/8 minus 1/8 gives us 6/8. Is that going to be our final answer? No, it's not. Well, we can bring the 1 over because it's 1 whole. And then we have 6/8, so we can divide both of those by 2. And we're going to have 3/4. 1 and 3/4 will be our final answer. That's what you should look for on the exam. Alright, now we're going to skip ahead. We're just going to skip 2. Ooh, why does it keep bouncing back? We're going to go right on to number 18, where we're multiplying fractions, just to keep it in order. Okay, so now we have 2/3 times 4/5. So we don't need a common denominator to multiply. And we're going to go straight across. This is confusing. A lot of people mix this up with proportions and a lot of other things, and they think, oh, multiplying is more difficult than it is, but it's really not. So we're going to have 2 times 4 is 8, 3 times 5 is 15. That is the answer you're going to look for on the test because it is in lowest terms. Okay, so what we're doing now is we have 4 to the 6 times 4 squared, and we're going to verify first that our bases are the same, and then we're going to look at our exponents. Well, our base is the same, so we can go ahead and write that in. And our natural inclination is to look at that multiplication symbol and go ahead and say it's 6 times 2 and give us 4 to the 12th. That's incorrect. When you have the same base and you're multiplying exponents, you actually add them together. So our final answer will be 4 to the 8th on this one. All right. On the next one, I'm going to show you, it's going to be a lot easier and it's not going to require a calculator and as much time. So let's move on to that one. The next one is 2 squared times 2 squared times 2 to the 3rd. So we're going to switch over. I'm going to write down the problem without holding the pen upside down. 2 squared times 2 squared times 2 to the 3rd. First, we're going to verify our bases are the same. And they are. So we're going to take the exponents of each and add them together. And we're going to have 2 to the 7th. Alright, I just happen to know that that is 128. So we are going to check and make sure that multiplying 2 squared times 2 squared times 2 to the 3rd is 128. So it's going to go ahead and bring them all down here, but I'm going to square them and cube them as I'm bringing them down. So I'm going to have 4 times 8. So we can do 32 and have 4. Well, we can already see here that this is going to be 8 and this is going to be 12 or 128. So yes, this works. This is how it, well, yes, this is how it works. But here's kind of a little proof for you so you can see why it works, why we add them together. Alright, I hope that helps because that was huge for me when I first saw it and actually had someone show it to me. So let's move on to number 26, I believe. Yep, looks like 26. And that is 3 to the 6th inside a parenthesis that is all being squared. So let's switch over to it. So here, the natural inclination is we're going to end up with 9 to the 36th power. Well, that too is incorrect. It is, actually, we keep our base the same, and then we multiply our exponents. So we have 3 to the 12th. So it kind of works where you look at PEMDAS and you go to the next big group anytime you have to deal with these. So parentheses becomes multiplication, multiplication becomes addition, and division becomes subtraction. Is it the best, easiest thing to remember for this test? No. But if you practice these, they are pretty easy to remember. Let's see what we have coming up next. Looks like we're actually moving out of the first competency now. Yes, we are. Alright, so how many inches are there in 45 feet? Alright, so they want to know how many inches there are in 45 feet. So the first thing I'm going to do is look at it and go, well, am I trying to get how many smaller units from a larger unit, or the larger unit into the smaller unit? Well, I know inches are smaller than feet. I know that there are 12 inches per foot. So I am going to know that inches are smaller than feet. So I can upscale, which means, or move up. So I'm going to end up with more of my inches, and I know that there are 12 inches per foot. So I'm going to take 45 times 12 and have 540. And that's how many inches are in a foot. And we move on to number 28. Find the unit price of 8 balloons for $1. Alright, so we have 8 balloons for $1. Well, this is simply a fraction. The whole amount spent is $1. And the number we got was 8 balloons. So we have 1 divided by 8, which is 1.25. We don't have a 1.125 coin, so we are going to round to the hundredths place, because that is where we do have denominations. And we're going to end up with 13. So there are 13 cents each. This is your approximate answer, and this is your definitive answer. It's 100% correct. You may see both on the test. It's common sense. If it asks you for the approximation or to round up, you're going to put 13 cents. If it wants a definite answer, you're going to put 0.125 as your answer. I'm willing to bet 10 out of 10 times they're going to want the rounded version to the whole cent, because it's not realistic to go to the grocery store and spend a 5,000th of a cent on an item if you buy your balloons at the grocery store. Alright, let's see what's up next. So now we're moving on to evaluating polynomials. We already have a video up on these, and hopefully by the time a lot of you are watching these videos, we'll have all of the videos up. But what we're going to do for number 29 is we're going to look at, we have 14. While I'm still in green. 14 m squared into the third plus 6m squared into the third plus 3m squared into the third. Alright, so what we have to do is we're going to first look at each variable. So we have m's and we have n's. So I'm going to go through real quick and just mark each one. Now I'm going to denote m squared, all m squareds, with another red line. I have an m squared here and an m squared here. Now I'm going to go to n where I have green. I'm going to mark into the third, and into the third with green. So this one we're really lucky. We have red, red, green, green, red, red, green, green, red, red, green, green. That is a surefire bet that you can go ahead and combine them, because they are all like terms. So we're going to end up, whatever our answer is going to be m squared into the third, because we are adding for each of these. And what we really just need to come off to the side here and see what 14 plus 6 plus 3 is, and that's 23. So we're going to have 23m squared into the third. And it's just that simple to evaluate polynomials when you're adding. You just make sure that each variable is raised to the same power so that you can combine like terms, which is exactly what we had here. So let's see what's up next. Oh, we're just moving on from addition to subtraction. And we have 14m squared n to the first minus 6m squared into the first. Well, this one's pretty easy. It's pretty much the same thing. We're not going to do it in color because you're not going to have color on the test and you just saw one. So we're going to do shapes. I am going to denote m with a straight line, and I'm going to denote n with a squiggly line. And then I'm going to go m squared, so anything that's m squared also gets the straight line. Gets the straight line into the first. I'll just go ahead and put it there. Gets the squiggly line. We're lucky that these are the exact same, so we know these are going to be m squared in. 14 minus 6 is 8. So now this is not on the pretest, but I'm going to go ahead and come aside and show you kind of what to do if you end up with something that's not the same. So if I have m squared n cubed n plus m squared n to the fourth, can we add those together? Well, let's see. We're going to come to m, we're going to mark m with a line, and we're going to mark the ends with another color line. Well, okay. And we're going to come back and mark in m squared with the same color, n cubed, but this is different, so we're not going to mark it. And this is different, so we're not going to mark it. We're going to pick a new color. So we have this color, and it looks like we need to stick with this color. So now we kind of have a problem here. So we can go ahead and say, yes, the m's can be combined, but these are all, this is one term. So we have to make sure all of them match. This is another term. Now if you think back to the, 2 or 3, 4 problems ago, what we have here is n to the third times n to the first. So what can we do with that? We're going to end up with n to the fourth. So now we have m squared n to the fourth plus m squared n to the fourth. So now we can go ahead and just, we'll do it quickly. Yes, yes. Those are the same. These are the same. Well, now they can be added. So we're going to end up with 2 m squared n to the fourth. Be careful. Keep your eyes out for that. See if you can find something that you can kind of force to be something you know all your terms could be to be alike. Now if this was n m squared n to the third, you could not do that. This would not have worked for us today. Alright, let's go on to the next one. Oh, inequalities. I know everyone loves inequalities. Alright, so we have 3m plus 2 is less than 7. Well, we're going to treat this exactly like an equation, and we're going to start by subtracting 2 from both sides. We'll be left with 3m is less than 5, and divide by 3, and we will have m is less than 5/3. That's all there is to it. Doesn't look like we have any more of these coming up, so let's do at least one more, and we're going to make it almost the same problem, but we're going to see a big change. And this is where a lot of people kind of get messed up. I'm going to make this negative 3m plus 2 less than 7. And we're going to go ahead and solve for it. Well, of course, we're going to do this step again. And we're going to have negative 3m is less than 5. But here's the big difference. And this is where a lot of people come and they say, well, I feel good about them, but I never remember this rule. This rule is always hanging me up, and I just kind of start guessing. Well, now we're in competency 2, so let's double the points of competency 1. So what we need to know is this rule. Anytime you multiply or divide by a negative, flip the sign, or the inequality sign. So now we're going to come back here, and we're going to even change color for effect and divide by negative 3, which then cancels here, leaving me with m is greater than negative 5/3. We divided by negative 3, so we flipped the sign. That is the most crucial thing to remember. This is where a lot of people miss their points. Multiply or divide by a negative, flip the sign. It was actually so important. I started with a lowercase f and made it an uppercase f. So I hope that kind of shows how serious it is. Alright, so now we're going to move on to number 32, and we're getting to the end of this pretest. Let's get everything back in order before we look at it. Okay, 32. The sum of two numbers is 41. One number is one less than twice the other. Find the larger of the two numbers. Alright, so we know the sum of two numbers. We'll call them x and y. And the sum is addition is equal to 41. That one's pretty straightforward. It's a lot of information packed in 6-7 words, so let's just look at it again. The sum of two numbers is 41. Well, we don't know the numbers, so we assign them two unknown variables, and we know that the sum of them, or adding them together, is equal to 41, so we went ahead and wrote that down. One of these numbers is one less than twice of the other. Find the larger of the two numbers. Okay, so we know one of these two numbers is one less than twice. One less than twice means, well, twice means we're multiplying. So let's just choose y to be the 2y minus 1. So 2 times, or one number is one less, so we have minus 1, then twice the other. Okay, and what are we missing here? Well, it's the other number. So we know that x is equal to 2 times 1 less than y. So what are we going to do? Well, we can move them. Sorry, I'm trying to remember the two ways I mostly see this. We can do it by substitution, or we can reorder them. I like to do it by substitution. It's the surefire way. It's less confusing. So let's do substitution first, and then maybe we'll do it the other way. Well, I know x is equal to 2y minus 1. So can I take this x and say that it's equal to 2y minus 1 and substitute it in? So now I'm going to end up with 2y minus 1, and we're going to put it in parentheses just to make sure we see that we really didn't change the expression at all, is equal to 41. So let's look at that again, because I know these are confusing and they're scary, and a lot of times scary problems just kind of shut your brain down. So we have x plus y is equal to 41, and we know that one number is one less than 2 times the other number. So we have this as 2y, doubling that number twice that number y, minus 1 is equal to x. So we know x is equal to this, so we just took the original equation and rewrote it without x, so we're only solving for one variable. Well, there's nothing out here, no negative sign, no 4, no 5, just a understood one, so we can drop the parenthesis. Well, now we're going to combine like terms. And we're going to have 3y minus 1 is equal to 41. And we're going to do some simple algebra. Plus 1 plus 1. We have 3y is equal to 42. Divide by 3. Y is equal to 14. Yes. Okay. So now we know one of the numbers is 14. So what do we do next? Well, we're going to come back to either one of these, original or the modified, and we're going to substitute in y. Well, I'm going to do it the easy way. So we have x plus 14 is equal to 41. Simple algebra. Minus 14 from both sides. X is equal to 27. So let's reread that sentence. We have our x and y values. I'm just going to go ahead and box them in, because that is going to be the answer. Or these are the two answers, but the absolute right answer says find the larger of the two numbers. Well, that's x. So what are you going to select on the test? 27. But we're going to check to see if this is right. So I'm going to go to the modified, and I'm going to substitute everything in. I'm going to say 2 times, well, y is 14 minus 1 should be equal to 27. And 28 minus 1 is equal to 27. 27 is actually equal to 27. So we did that one right. It's all about, this is less of a math problem and more of a reading problem. So take your time. All those problems where we flew right through them and they were so easy for us, this is where we spend some of that time we banked. These are the types of problems where you really spend time that you think you don't have. Just remember, you've built it up on the easier questions. This is where you spend it. Don't finish the test with 20 minutes to go. Use every minute you have. Alright, let's move on to the next one. Now this one I can show you two ways to do it. One's the lazy way, which I prefer, and one is the way all the study guides and stuff show you. So we have the sum of two consecutive integers is 111. So x plus y is equal to 111, when in reality we don't have two unknowns. We know that they are consecutive, meaning they come in order 1, 2, 2, 3, not 3 and 5. So they're going to count. So I'm going to go ahead and get rid of y. We don't need that. We're going to have x plus, and then the first number plus 1 is equal to 111. I said I was going to start with the lazy way, but we naturally fell into the way the book wants us to do it. So we're going to do it that way first. And we're going to look at this. This is an understood 1, as we keep saying. I'm going to go ahead and distribute it in. X plus 1, giving me 2x plus 1 is equal to 111, or 111. So I'm going to subtract 1. 2x is equal to 110. Oh, divide by 2, and we have 55 is equal to x. So we're going to go back in, and where we have this problem. Sorry, this was throwing me off since it wasn't originally there. We're going to rewrite it just for clarity. And we're going to go ahead and substitute in 55 for x plus 55 plus 1. So we're going to do our inside our parentheses first. And look at that. We have our two numbers. So the sum of two consecutive integers is 111. Find the value of the smaller integer. So we're going to pick 55. Now we're going to cover the lazy way, or my way to be honest. So I know we need the sum of 111, and we have two numbers. So we're going to divide 111 by 2, and we're going to have 55.5. Now, that's it. The rest of it I do mentally. I'm going to show you written out on a number line. This is done in my head, and it only takes a few seconds. Once I show it to you, you say, oh, that was obvious. Why waste your time showing it on a number line? Well, this is exactly just the way to do it. This will help people who are visual learners visualize it. So here's my 0 on the number line. I'm going to go out here, and I'm going to mark 55.5. Well, that's the halfway between 1 and 11. That's halfway between 1 and 11. So now I need two consecutive integers that sum up to it. Well, it's going to be the numbers on either side of the halfway mark, 56 and 55. Now, since I want the smaller of the two, I'm taking 55 every time. That's really all there is to it on the lazy way, or the quick way, or the way that I prefer. Alright, so number 34. The difference between two integers is 12. The sum of the two integers is 2. Find both of the integers. Well, first, we're going to just talk about this. We have the difference. Difference is the number you would count on a number line between the two integers. The sum of two integers is 2. Simply adding them together. So we need to figure out which way are we going to be better off finding them. Well, I'm thinking the difference is going to be the best approach to start with. So let's do that. So we have x, and then, like I said, the difference is the distance between. So since I started with x here, I'm going to go 12 more. That's the distance between. So this is really, here if we had made this x, this would be x. Here would be x minus 12. But we went ahead and just did x plus 12. So let's bring that back over and add them in parentheses so we know to do any operation within them first if it's relevant. And we know that the sum of them is 2. So now we're going to start solving for it. Well, we're far enough along in the review. We don't need to say again that there's an imaginary 1, even though I am. So let's just drop this and add the two x's together. You know that we're going to have 2x plus 12 is equal to 2. And do simple algebra and be right along to 2x is equal to negative 10. Divide that by 2. X is equal to -5. Oh, there's our first value. So what do we do next? Well, X is equal to -5, so let's throw it in there. -5 plus 12 is equal to 7, giving us our next unknown. Ooh, all over the place here. And then we can check it by making sure the sum of the two is 2, and it is. So there we are. Now if I lost you a little bit on this step, let's just look at it real quick. So I know X is -5, and I know here we have -5 plus 12 is equal to 2. So -5 plus -5 is -10, plus 12 is 2. So instead of worrying about doing -5 plus -5 plus 12 equaling 2 and simplifying and doing all that, I went ahead and skipped right into just this, and knowing that X plus 12 is 7. So our 2 is 7. So once both of the integers, so we're going to look for a solution that has 5 and 7. Alright, let's move on to the next one. Alright, Leslie is a biologist. Brian will never be a biologist. Sorry, there's a lot to erase on the other page, so I'm just trying to fill it in without having silence. Leslie is a biologist. She is going to randomly select one animal from her lab to study. There are 5 salamanders, 3 crayfish, 12 minnows in her lab. What is the probability that she will select a salamander? Doesn't say it, but we're going to make sure any of our answers are in the lowest, simplified to their fullest extent. So let's switch over to the drawing area. So we have 5 salamanders, we have 3 crayfish, and we have 12 minnows. So anytime we're doing probability like this, the first thing we want to know is the total possible number of things that we can draw from. So we're going to add 5 plus 3 plus 12. 5 plus 3 is 8, plus 12 is 20 possible things. 20 total. So we're going to call that possible outcomes. And we're going to say that's equal to 20. And then the wanted outcomes. And we want what do we want? Well, we want a salamander. How many salamanders are there? 5. So the possible number versus the wanted number, let's go ahead and use the number sign, is 5 over 20. Well, 5 is divisible by 5, 20 is divisible by 5, that's 1/4. And that is an answer. These are all answers, but I'm going to tell you they are going to want it simplified. And to throw you off, because you're going to have a fraction doing it this way, it may just throw this in there for you. So that's another possible answer. If you don't know how to convert fractions to decimals, there's a video on that. And I'm going to save the time now because we're almost done. And we're quite a bit into this video, so I don't want to keep doing it. Alright, the next one's very similar. And I just skipped ahead because I'm on the wrong screen. Alright, you randomly draw a marble from a bag. Out of a bag that contains 20 marbles. 12 of the marbles in the bag are blue. What is the probability that you will draw a blue marble? Alright, so we have 20 total marbles. I'm not going to write marbles. 12 of the marbles are blue. It doesn't tell us what the rest are, but does it matter in the question? Let's go back to it. What is the probability that you draw a blue marble? Nope. So we're going to take total outcomes over wanted outcomes, or wanted number, the number of possible that you can have. So we have 12 blue over 20, and then those are both divisible by 4, leaving us with 3/5. So there's a 60% chance that we will draw a blue marble. But what is the probability that you do not draw a blue marble? Well, how the heck do we get that? So It's actually a lot easier than it sounds. We're going to subtract 12 from 20, and we'll have 8. That is 8 remaining marbles. Doesn't matter the color because it's not asking the color or what we may possibly get. It's not saying are you going to get a brown marble. It's just what is the probability that you're not drawing a blue marble. That is, a lot of people tell me that tricks them and they don't know what to do. They just look at it and say, I don't know. Well, the probability that you do not draw a blue marble is now 8 over 20, which simplifies to whatever 40% comes out to. So let's do it by 4. We're going to have 2 over 5, and that's 40%. So we can use the 60% and the 40% I got, add them together, and we have 100%. So now we know we have accounted for every marble in that bag. So that's one way to do it, or we can do 2/5 plus 3/5, which gives us 5/5, which is equal to 1, which is equal to 100%. So yes, we have accounted for every marble in the bag. Now, here's a question I like to ask now, because this is throwing a few people through the loop on tutoring. So since you're at home in your own private setting, you don't have to worry about being embarrassed in front of anybody else in the room or stumbling over it. But let's say we have a bag of 20 marbles. 10 are blue, 5 are yellow, and 5 are brown. What is the possibility of you drawing a red one? Alright, while I wrote that, you've had a few seconds to think and say, well, a lot of people say there's no information on the red, so how do I know? Well, that's right. There is no red, so 0%. It's the same chance of drawing a working automobile or a skyscraper out of a little bag containing marbles. It's not going to happen. 0%. They're not in there. And I don't think it's going to be on this test, but it's just one of those things to kind of help you think about the bag. If it's not in there, you have a 0% chance. And that really doesn't affect our outcome. Here we have 50%, 25. So this is 50. This is 25. And this is 25%, which adds up to 100%. So there is no room for the red marble. It works both ways. So I hope that helped. All right, let's switch back over and see what number 37 looks like. Thomas is at a car dealership. He's going to randomly select the vehicle to test drive, and there are 13 trucks, 8 vans, and 4 compact cars. What is the probability that Thomas will test drive a compact car? Well, we have 13. Let's switch over. We have 13 trucks, 8 vans, and only 4 compact cars. So we have here 12, 25 total. So now we know what our denominator is going to be. 25. And he wants to know if he's going to drive a compact car. Well, that's 4 out of 25. I don't know if there's really anything else to this question. It doesn't seem to be. The only other thing we can do real quick, since this is the last question, is check and see if the vans and everything else makes sense. So we're going to see if we have 100% accounted for here. We have 8 vans plus 13 trucks. And we have 21, 25 out of 25. Yep, everything is accounted for. So this is the whole number of cars he has on the lot. Not Thomas, but the dealership. And this is the part of that whole that are compact cars. This is the part of the whole, or all of the cars, that is a van. And he has 13 parts of his 25 car inventory or vehicle inventory is trucks. that's really all that means. There's a lot more explanation of that in the fractions videos coming in the near future, or if you're in the near future or future, they're already up. Alright, I hope this video helped make sense of the GK pretest that I